Bismillahirrahmanirrahim, my dear students. Here is your mathematics teacher Muhammad Amjad Saeed from Pakistan International School, Taiz, Saudi Arabia. Today we will continue our lecture number 61 and exercise 6.3. Exercise 6.3. Before we start our exercise 6.3, I want to give you the idea about arithmetic mean between any two particular numbers. For example, let A be the arithmetic mean between A and B, then A, capital A and small b is AB, is an AB. This is arithmetic progression. According to definition of arithmetic progression, common difference between any two consecutive numbers remain the same. That's why second minus first is equal to third minus second. Second minus first is equal to third minus second. So we have A plus A is equal to A plus B. Shift this A capital to the left hand side and we can have 2A is equal to A plus B and A is equal to A plus B over 2. Dear students, this is the formula for the arithmetic mean. So arithmetic mean formula between any two numbers is A is equal to A plus B over 2. Also, you know that in case of arithmetic progression, you know that we can find any term by adding a constant number which is known as common difference to the previous number. Yesterday I told you last time that whenever you want to find the number in arithmetic progression, then you have to add a constant number in the previous number to get the next number. Here we have question number 2, exercise 6.3. If 5, 8 are arithmetic means, if 5, 8 are two arithmetic means between A and B, then we have to find value of A and value of B. As 5 and 8 are two arithmetic means between A and B, therefore A, 5, 8, B is an AB. Dear students, this is an arithmetic progression that 5 and 8 are two arithmetic means between A and B. So A and B at the ends, at the corners, and 5 and 8, these two numbers will be in between them. So this is arithmetic progression. Now by definition, what is that? First, second minus first is equal to third minus second. Second minus first is equal to third minus second. This is common difference. Similarly, third minus second is equal to fourth minus third. Third minus second is equal to fourth minus third. This is common difference. You know that common difference remains the same between any two consecutive numbers. So here is 5 minus 8 is equal to 3 and 3 is equal to B minus 8 and B is equal to 3 plus 8. Here is 5 minus 3 is equal to A. So A is equal to 2 and B is equal to 11. So dear students, what are the values of A and B? This is 2 and this is 11. these values are correct and logical because you know that the common difference between any two consecutive terms remain the same. 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3. So common difference is same for all these values for A and B also. So these values are correct, and this was your question number 2. Dear students, after that, according to reduced syllabus received from Federal Board, we have question number, yes, we have question number 3. Find 6 arithmetic means between 2 and 5 and find 4 arithmetic means between 2 under root and 12 or 2 under root. That is question number 4. So what is question number 3? Find 6 arithmetic means. 6 arithmetic means between 2 and 5. We have to find 6 arithmetic means between these two numbers, 2 and 5. Let A1, A2, A3, A4, A5 and A6 be 6 required arithmetic means between 2 and 5. Then 2, A1, A2, A3, A4, A5, A6 and 5 is an AP. Dear students, A1, A2, A3, A4, A5, A6 be 6 arithmetic mean between these two numbers. Then in between 2 and 5, these are 6 arithmetic means. So this is an AP. So from this sequence, we have A is equal to 2 and 1, 2, 3, 4, 5, 6, 7 and 8. So number of terms are 8. And A8 is equal to 5. 8th term value is 5. So we have to find B. Using general formula for arithmetic progression or nth term, An is equal to A plus n minus 1 into D. What about An? This is A8 is equal to A plus 8 minus 1 into D. Use the value of n as 8 here. So A8 is equal to 5. That is equal to A plus 7D. What about the value of A? This is 2. Using value of A as 2, that will be 5 minus 2 is equal to 7D and 3 is equal to 7D. So what about D? D is equal to 3 over 7. Dear students, this is common difference. D is equal to 3 over 7. Now it's very easy to find A1 by adding this common difference D in first term, it will become second. In second term, you will add D and you will get third term. Similarly, A3 can be obtained by adding common difference D in A2, and in this way you will find other values. In arithmetic progression, every term can be obtained by adding this common difference in the previous term. You can get the next term. Now, A1 is equal to A plus D. 2 plus 3 over 7 That is 7 2 is the 14 plus 3 is 17 over 7. Then what about A2? A2 is A1 plus D. 17 over 7 plus 3 over 7. A2 can be obtained by adding D and A1. A3 can be obtained by adding D and A2. Here is 20 over 7. What about A3? A2 plus D. 20 over 7 plus 3 over 7. That will be 23 over 7. A4. A3 plus D. 23 over 7 plus 3 over 7. 26 over 7. Similarly, A5 is equal to A4 plus D. 26 over 7 plus 3 over 7. 29 over 7. And A6 is A5 plus D. Dear students, this will be 29 over 7 and plus 3 over 7. That will be 32 over 7. And remember that if you add D in A6, then you must get 5. Again, I am repeating, this is confirmation of your answer in fact. So if you add common difference D in A6, then you will get 5. 32 over 7 plus 3 over 7 is 35 over 7, and 35 over 7 is 5. It means that all these numbers are correct because we are getting 5 by adding D and A6. Dear students, I hope that you understood this question. After this, we have question number 4. Question number 4. Question number 4. Find 4 arithmetic means between 2 under root and 12 over 2 under root. Here is question number 4. Find 4 arithmetic means. 4 arithmetic means between 2 under root and 12 over 2 under root. Let same method. Let A1, A2, A3, A4 be 4 required arithmetic means between 2 under root and 12 over 2 under root. Then 2 under root, A1, A2, A3, A4, 12 over 2 under root is an AP. This is arithmetic progression. What about A? A is equal to 2 under root 1, 2, 3, 4, 5, 6. So n is equal to 6 and A6 is equal to 12 over 2 under root. We have to find value of D. Dear students, if you find the value of D common difference and you add this value of D in first term, you will get A1. Then add D and A1 to get A2. So here you can apply the formula An is equal to A plus n minus 1 into D. This is A6 is equal to A plus 6 minus 1 into D. What about A6? 12 over 2 under root. What is the value of A? 2 under root. That is 5D. So 12 over 2 under root minus 2 under root is equal to 5d. Dear students, you can take 2 under root as LCM and you can have 5d is equal to 12 minus 2 over 2 under root. Remember that if you take 2 under root as LCM, 2 under root cancelled out, we are left with 12. Then 2 under root is multiplied by 2 under root, that becomes 2. It is 5d is equal to 10 over 2 under root. And d is equal to 10 over 2 under root. And 5 was multiplied here. On the other side it is divided and it can cancel. This will be 2 over 2 under root. Dear students, d is 2 over 2 under root. Now we can find a1 is equal to a plus d. What about a? 2 under root and d is 2 over 2 under root. You can take 2 under root as LCM. So 2 under root into 2 under root is 2 and this is cancelled out. It will be 4 over 2 under root. And a2 is equal to a1 plus d, that is 4 over 2 under root plus 2 over 2 under root, that will be 6 over 2 under root. If the denominator is same, you can write down as it is and numerator simply added and subtracted. a3 is equal to a2 plus d, this is 6 over 2 under root plus 2 over 2 under root, that is 8 over 2 under root. Dear students, we have a4, that is a3 plus d, 8 over 2 under root plus 2 over 2 under root is equal to 10 over 2 under root. Dear students, if you add this common difference d in your a4, it will become 12 over 2 under root and that is your last term. So it means that your different terms, different numbers are correct. So I hope that you understood this question. Dear students, after that, we have question number 7. Question number 7. Question number 7 is a special type of question, and for your information, I am telling you this question number 7 is also in geometric mean and harmonic mean and arithmetic mean. So the same type of question is in all the 3 topics: arithmetic mean, geometric mean and harmonic mean. And you will find that inshallah. We can use the definition of arithmetic mean and definition of geometric mean to find the unknown value of n. Here we have question number 7. Find the value of n so that an plus bn over an minus 1 plus bn minus 1 may be arithmetic mean between a and b. First of all, you must understand the nature of the question. Dear students, what is that? Find the value of n so that an plus bn over an minus 1 plus bn minus 1 may be arithmetic mean between a and b. Then, by definition, an plus bn over an minus 1 plus bn minus 1 is equal to a plus b over 2. This may be equal to arithmetic mean between a and b, and this is arithmetic mean between a and b. This is the formula. Having cross multiplied, dear students, cross multiplication. 2 into an plus bn is equal to a plus b into an minus 1 plus bn minus 1. You can have 2an plus 2bn is equal to a into an minus 1 plus a bn minus 1 plus an minus 1b and plus b into bn minus 1. 2an plus 2bn is equal to an 1 plus n minus 1 and abn minus 1, an minus 1b and b1 plus n minus 1. Dear students, you know that if the bases are same, their powers are added. Bases are same, powers are added. Here 1 and 1 cancelled out, 1 minus 1 cancelled out. Dear students, we have 2an minus an. I have shifted an to the left hand side. And plus 2bn, and this is bn. It is also shifted to the left hand side, minus bn. So an minus 1b plus a bn minus 1. an minus 1b plus a bn minus 1. 2an minus 1an, that is an plus bn. an minus 1b plus a bn minus 1. Dear students, you can bring an minus 1b to the left hand side. an minus 1b is equal to abn minus 1 minus bn. an minus 1b is shifted to the left hand side and bn is shifted to the right hand side. Dear students, look at the whiteboard very carefully. This an can be written as an minus 1 plus 1. May I write down? Definitely I can write down, because minus 1 plus 1 are cancelled out. Here minus 1 and plus 1 are cancelled out. Now break down this power. an minus 1 into a minus an minus 1b is equal to a bn minus 1 minus bn minus 1 into b power 1. In fact, here we have broken down the powers, bn minus 1 into b1 and an minus 1 into a. Dear students, from left hand side you can take common an minus 1 into a minus b. On right hand side you can take common bn minus 1 into a minus b. Dividing both sides by a minus b. So you can have an minus 1 is equal to bn minus 1 and shift this bn minus 1 to the left hand side. Here is bn minus 1, that is equal to 1. Remember that bn minus 1 is shifted to the left hand side, on right hand side 1 left. Some students say this is 0 left. Sometimes the students think that this is 0, and at that step this will be wrong. Dear students, you know that what is the step wrong or correct? How can you check that? Basically, if you simplify this, you must go back. Backward proceeding must be possible in case of right steps. This bn minus 1 is shifted to the right hand side, so it will become an minus 1 is equal to bn minus 1. If it was equal to 0, you can never get this above line. So that's why this is divided, actually this division both sides by bn minus 1. Here is 1 and here is 1. Now you can have a over b whole power n minus 1. This power, an minus 1 power and bn minus 1 power. You can write down combined power. And dear students, you know that what is meant by 1? Actually, 1 is anything power 0. That is always equal to 1. Anything power 0, but you must not say that 0 power 0. It is not defined. So you can have a over b power 0 because it will be equal to 1. But by writing this, we can compare them. Base is equal to base and power is equal to power. So n is equal to 1. Dear students, that was your question number 7. I hope that you understood this question. That was your question number 7. After that, we have next question. But in my opinion, this next question is not related to the formula used in exercise 6.3. My dear students, this last question is relating to the next exercise formula. So that's why you must have the idea about the next exercise questions, and then you will be able to solve your last question of this exercise. So inshallah we will do it, but remember that we must have the idea about the next exercise 6.4. Formula applied here, then we can have. Exercise 6.4 formula is relating to the sum of arithmetic series. Sum of arithmetic series. First of all, you must understand what is meant by arithmetic series. What is meant by arithmetic series? Sum of terms of arithmetic progression is known as arithmetic series. Sum of terms of arithmetic progression is known as arithmetic series. For example, we have a plus d, a plus 2d, up to so on. This is arithmetic progression. If you add these terms of AP, a plus d, plus a plus 2d, plus so on, is known as arithmetic series. Sum of terms of arithmetic progression is known as arithmetic series. Dear students, before we start our next exercise, I want to give you the idea about the sum of arithmetic series formula. Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the sum of arithmetic series formula of n terms. Sn is equal to n by 2, n means number of terms, a means first term, n is number of terms, d is common difference. So in this way we can have Sn is equal to n by 2, 2a plus n minus 1 into d. Exercise 6.4 and question number 1. Find the sum of all integral multiples of 3. Sum of all integral multiples of 3 between 4 and 97. 4 and 97. So dear student, first of all, you must write down the arithmetic series between 4 and 97, and remember that these are all integral multiples of 3. So what will be the series? The given series is 3 to the 6, 3 1 the 3, but 3 is less than 4, then 3 to the 6, 3 3 is the 9, 3 4 the 12, and then 3 5 the 15, up to so on to 96. Sum of terms of this one is 96. So what will be, what about that? A is equal to 6. What about D? D is equal to second minus first. 9 minus 6 is equal to 3. And remember that AN is equal to 96. AN is equal to 96. Actually, you have to find the value of n. First, you have to find the value of n first, and then you can apply this formula Sn divided by 2. So here is using an is equal to a plus n minus 1 into d. An is 96, a is 6 plus n minus 1 into d is 3. 96 minus 6 is equal to 3n minus 3. Here is 90 plus 3 is equal to 3n. 3n is equal to 93, and 93 over 3 is equal to n. Dear students, you have n is equal to 31. N is equal to 31. We have found the value of n. We know about the false values of A and D also. So now we are able to apply this formula Sn using Sn is equal to n by 2 into 2a plus n minus 1 into d. What about n? 31 over 2. 2 into a is 6 plus 31 minus 1 into d is 3. Here you can apply 31 into 2, 31 over 2 into 12 plus 30 into 3 is 90. 31 over 2 into 102. So you can have 51, 31 into 51. You can multiply. It will be 1581. 1581, that is your answer of your first question of exercise 6.4. You can check it. Yes. 6.4. 1581. Yes, this is the correct answer. So that was your question number 1 of exercise 6.4. Dear students, after that we have question number 2, sum the series. We have question number 2, sum the series. Sum the series. We will apply the same formula. So remember that we will apply the same formula for sum of n terms of arithmetic series. So in this way you can have the value as value of Sn. A report term will be given. Here we can apply this formula. So I am giving this formula here to use it again. So dear students, we have question number 2. We have part number 1, 4 and 6 part. In my opinion, in question number 2, part number 1 and part number 5 are, rather part number 4 are same and 6 is a little difference. So we can take part number 2 or part number 4. Here is minus 8 minus 3 whole 1 over 2, minus 8 minus 3 whole 1 over 2 plus 1 and plus so on to A11 2 plus A11, 11th term. Dear students, what is A? A is equal to minus 8 and D is minus 3 whole 1 over 2 minus into minus 8, actually second minus first. So 3 to the 6 and 7 minus 7 over 2 plus 8. So what will be that? 2 8 plus 16. 16 minus 7 is 9 over 2. 16 over 7 is 9 over 2. And what about n? N is 11. So you have to find Sn using these values here in this formula. So Sn is equal to 11 over 2 into 2 into minus 8 plus 11 minus 1 into d is 9 over 2. So dear students, this is 11 over 2 minus 16 and plus this will be 10. This is 10 into 9 by 2 to find the 10. 11 over 2 into minus 16 plus 45. And now you can have 45 minus 16. This will be 11 over 2 into 29. So 11 over 2 into 29, we can have 29 multiplied by 11, 319 over 2. So dear students, that is your Sn, sum of n terms, sum of elementary terms of this formula according to this question. Here we have 6.4, yes. So this is 159. So no need to divide that 159.5. No need to divide. You can leave this answer as it is. Okay. After that, we have part number 6. What is part number 6? Part number 6 is 1 over 1 minus x under root, 1 over 1 minus x under root plus 1 over 1 minus x, 1 over 1 minus x plus 1 over 1 plus x under root plus so on to n terms. Dear students, here we have arithmetic progression in which a is equal to 1 over 1 minus x under root and b is second minus first. Remember that 1 over 1 minus x can be written as 1 minus x under root and 1 plus x under root minus 1 minus x under root. 1 minus x can be written as 1 minus x under root 1 plus x under root. If you multiply by the formula, what's the formula? A plus b. A minus b is equal to a square minus b square. So we have applied this formula here. If you apply this formula, you will get this again. But it will be easy for you to understand now. You have LCM 1 minus x under root 1 plus x under root. Both are cancelled out. We have 1 here minus into 1 minus x under root cancelled out. We have 1 plus x under root. You can open up 1 minus 1 minus x under root over 1 minus x under root into 1 plus x under root. This is cancelled out. So dear students, we have this value of d, and up to n terms mean n is equal to n. So we have to find Sn. Applying the values here in this formula. Yes, in this formula we can apply the values here. So dear students, this is n over 2 into 2a. What about a? 1 over 1 minus x under root plus n minus 1 into d. d is minus x under root over 1 minus x under root 1 plus x under root. n over 2. Now you can take LCM 1 minus x under root 1 plus x under root. This is cancelled with that. 2 into 1 plus x under root plus n minus 1. Both are cancelled out. N minus 1 into minus x under root. Here we can have n over 2. 2 plus 2 into x under root. That will be minus n into x under root plus x under root whole divided by 1 minus x. Remember that if you multiply them, you will get it again. At the end, we have multiplied, we have applied these formulas, and we got that value. And here is n over 2 into, we have here we have 3 into x under root minus n into x under root plus 2 over 1 minus x. Dear students, 2 into x under root plus x under 3 into x under root. And here we can have n over 2 into 3 minus n into x under root plus 2 over 1 minus x. This may be your answer, dear students. That is your x under root is taken common from first two terms, and this way you can have your answer of part number 6 of your. This is part number 6 of your question number 2, exercise 6.4. I hope that you understood these questions, and inshallah we will do next question in the next lecture. Okay, Allah Hafiz and Assalamu alaikum wa rahmatullahi wa barakatuh.